Getting things to be displayed to the subject is kind of one of the major topics that people need to learn about, and we're going to go through a few of the particulars of that today. But first, there's some background that's really useful to know before we get too far into this. So this is our schematic of the Kinarm, of the lab setup. The really important things to notice here are, okay, the visual information, or the information about things you want to display, is created on the robot computer at 1 kilohertz and passed to the dexterity computer at 1 kilohertz. And then the dexterity computer itself actually is what draws things on the display, and it does that at 60 hertz. So this has several implications to it. The first of which is that not everything you attempt to draw will be drawn. In fact, most of the kind of visual information that is created is thrown away. Now, so that means if you want something to show up on the screen very, very briefly, you can't just for like one kinematic frame, like 1/4 millisecond frame, say, please draw this and then stop, because it's very unlikely to be drawn. So there are ways to get that feedback to figure out how to draw something for exactly 160 hertz frame on your subject display. But in general, you'll have to draw something for a little while to be certain that it actually gets drawn. So if you need much more precise control, we have some example code on how to do that, and there are ways, but just to be aware, the visual display is not drawn or is not updated nearly as quickly as the robot itself is running. Okay. In terms of library blocks that are available to you, this is all of the blocks that are available for video, for putting things on the screen. We'll be going through each of these in some detail as we go through. We've seen a couple of them already, and we will start here. So this is kind of your most basic code for putting something on the screen. One of the terms I'm going to be using regularly is a V code. So you can see these blocks output V codes, and this block takes in a V code. So a V code is just a visualization code. It's really just an array of data that we know how to interpret to say, oh, well, based on this array of data, this is going to be a circle. It will be red. It will be at this location. So it's just a properly encoded or a specially encoded array of data. Now, having said that, the show target blocks, they will create a V code. So based on information that's in the target table, you have to tell it, I would like to show this target out of the target table, say target 1, that'll be the first row, and the block itself will go into the target table, pull out the information that's required in order to create your red circle that's 1 centimeter in radius. And again, we'll be going through exactly how that works. Next important thing, these V codes all need to be put together. Just use a matrix concatenation block to do that. And once those are all concatenated into one large matrix, this process video commands block is what actually takes all of those V codes and pushes them across to the dexterity computer to be actually drawn on the screen. So you don't need to do anything with the process video commands block. It just needs to be there in order for the display to actually be updated. Okay. How does this block work? The show target block, you can see on it, there's this little listing of columns. So if you double click the block, when you double click the block, you will get this user interface come up, or this little dialog come up, and you can see that these columns are defined here. So what do they mean? So in this case, when we're dealing with a circle, the this array means this is the column in the target table to get the fill color. This is the column to get the stroke color. The stroke being, if you have a circle, it will just, the stroke for a circle is basically just a band around the outside of the circle. If you have a square, same sort of idea. Stroke width, how wide is that at that outline if you're going to use it. And for a circle, we also need a radius. So these columns, you can find all of them and what you need to provide if you click on the help button for this block. All of our blocks have help buttons so that you can, and we try to make the help as useful as possible. So, you know, we try not to leave these things too much of a mystery for you. Now, the way this works then is when you tell the, so you can actually, rather than just specifying column numbers, you can actually use them by name, which is a much better way to do it. So here's an example showing this all by name. So we have our parameter table definition block where we have defined the fourth column in the target table as a color column. So we know that the first thing we need to provide here is the color, the fill color. So this is saying when you show a target, go to the fourth column, 1, 2, 3, 4, and pull the information out of that column in order to grab the color for the target we're going to show. So in this case, if we're showing target 1, it's going to be a 1 centimeter red circle. And you can also see from the parameter table definition block, we've got this label. So color, we pull this label out and put it actually in your table so you can line up your data. So does that make sense, hopefully, to everyone? And don't see any hands going up, so. Now, of course, you don't want to necessarily just show circles. You have several other options. Circle, ellipse, rectangle, line, triangle. Those are the basic shapes that we allow. There's a couple of others that we'll go over as well. Now, if I change the shape that we're looking at, so we go to a rectangle, that's going to change the required information. And so for a rectangle, we need the same first 3 pieces of information, the fill color, stroke width, but then for a rectangle, we need a length, height, and rotation as well. You can see some of these values are zeros. 0 means don't bother doing that. So in this case, say the rotation is 0. The rotation column is 0. So that means don't even bother looking for rotation data. We're not going to use it. Or stroke and fill, don't bother looking for stroke and stroke width data. Don't even bother looking for it. So, and again, as you change these different shapes, this array is going to change number of elements that are available to fill in. Just hit that help button, and that will tell you for a rectangle, these are the columns you need to provide us, or for an ellipse, these are the columns you need to provide us. Okay. So when you're showing a target, you've got several other options as well. So the first one we'll look at is your target states. So by default, a target has we have one state for a target, which is basically it can be on or off. If we want a second state, this is you can see we now drop down and we have the second state information. So you still need to provide us all of the same information here. So in terms of fill color, stroke width, and radius, but you can provide us different columns. This is really useful when you want to do something like have a target be red until someone reaches it, and when they reach it, it goes green. So in that case, you've got this target state input here, and you would start it out as 0 for please don't show this target, and then when you want the target to show up red, you pass in a 1, and then someone's reached it, so I'm going to change the target state to 2. Now it shows up as green, for instance. So that way you can have a single target with all of your positional and size information that you want, and actually just change its color without having to point to different targets and do anything more sophisticated than that. Target opacity is how see-through is a target. So a target can be a solid color, or it can be you can be able to see through it slightly. So the default value is an opacity of 100, meaning it's a solid color. You can actually change that either in this block mask. So this user interface is called a block mask, just in case that hasn't come up yet. And you can change the value here. If you wanted it to always be 50%, you could do that. But the more interesting thing to do is change this source for opacity value. So by changing the source for opacity to a port, you can see, let's see if I go back here, you can see we have 2 inputs, and now we have a third input for opacity. So this would allow you to do things like fade a target in or out if you wanted to dynamically. So this is saying, pass in an extra number that tells us what to put the opacity at. So yeah, you'd be able to dynamically fade a target out if you wanted to, or dynamically bring it, make it visible. And next we have where to display a target. So by default, you can see by default we always show targets on both the subject and operator display. So that means that the subject gets to see the target, and then in dexterity, as you're running the task and you can see that view of the workspace, we will show the targets in there as well. You can have a target show specifically just to the subject or just to the operator as well if you needed that. So that would be for something like if you were trying to either maybe blind the operator to exactly what happened with the subject, or if you needed to maybe show a score or something like that to the operator, but you didn't want the subject to know how they were doing. So something that's very useful to do, obviously, is show the hand feedback. The hand feedback is, if you've been using a Kinarm, or if you've seen in some of these videos, there's going to be a little white circle that pops up at either the subject's fingertip if you have an exoskeleton, or at the center of the handle if you have an endpoint. And it's about showing where the subject's hand is at any given time. So we have a nice convenient block for doing that, which is this hand feedback block. It's going to by default give you a 1 centimeter radius white circle over the hand. And it does a few extra things to make sure that hand feedback is where is approximately where the hand is at any given time. There's something else that's useful to know that this does is it's something called we call it a feed forward. So going back to that diagram we had earlier of the system schematic, where the V codes need to start at the robot computer and eventually turn into something that's displayed on the screen. Well, nominally the time from you saying please draw this on the screen until pixels on the screen light up is about 50 milliseconds, 50 milliseconds. So, and that's, we have some detailed information in our guides about why that is and where those delays are. But what the hand feedback block does is some predictive work to figure out where the hand is going to be in about 50 milliseconds in order to properly draw where the hand feedback will be. And if you don't do that, the dot for the hand feedback always will lag behind where your hand actually is as it's moving around. The other important thing to note in this diagram is you see that the hand feedback block here is the last thing that's going into this concatenation matrix. And that's kind of important because we draw the V codes in the order that they are passed to us. So in kind of more computer science terms, that this is we obey a Z order as we're drawing. So what that means is this show target block is going to be drawn first, this one second, and this one last. So if you're doing some coding and you suddenly see, oh, my hand feedback is always disappearing underneath my targets, it's going to be because your hand feedback is being drawn first and then your targets. So if you draw the hand feedback first, then anything else that's drawn will be drawn over top of it and potentially obscuring your hand feedback. So if you see that happening, that means you need to just change the concatenation order for this matrix and put the hand feedback last, assuming that's what you want. Okay, so with the hand feedback, we give you some flexibility for playing around with it, because obviously not everyone just always wants a white circle on. There's other things one might want to do. So if you double click the hand feedback block, you're going to see this this dialog pop up. So the first thing you can do is you can control the status of the hand feedback. That is it on or off? So for some experiments, it's useful to have the hand feedback on for a portion of it, but you want it off for another portion of it. So that's what you would use this for. So you could, by changing the status to between 1 and 0, you can say whether or not the hand feedback will be on or off. There's also controls for doing that within your task protocol. So if something isn't working correctly with your hand feedback status, then there's a setting you might need to change in your task protocol to allow the task program to have full control over this. The next thing, not everybody wants a white circle for their hand feedback. So you can actually tell us what you would like the hand feedback to look like. And if anybody out there has run the object hit task or the object hit and avoid task, you'll notice that that uses a green paddle at the hands and instead of the white circle. So in order to do that, we use the block in this mode. And what this is going to do is say, give me a V code for the arm to be assessed and the contralateral arm, and then we will output the appropriate. We will basically take those V codes and move them to the right place for the hand where the hand actually is. So you just need to provide us the shape that you want, and we'll figure out what the XY location is for those things to be drawn. Okay. Yesterday we used a bit of the hand and target block. So the hand and target block, this obviously outputs a vector. You can see here the output is called vector. So what this actually outputs is a 1 or a 0 for whether or not you're in any particular target in the target table. So in this case, it would be a vector of length 11, and if your hand was in target 1, you would get a 1. In this output would be 1 0 0 0 0 0 0. So yeah, this will tell you if you're in one or more targets that are defined in your target table at any given time. Now, something that's commonly done is you might not want to actually use the visual radius and all for determining whether or not someone's hand is in the target. It's often desirable to use what we would refer to as a logical radius. So you can see here, this hand and target column is saying, well, I should point this out too, that right now this is being configured for a circle, and it's pulling the radius for the circle from column 3. So if we wanted to, we could say, no, pull the radius for the circle from column 5. So in this case, this would virtually make the circle slightly larger, so you don't have to be fully inside of it in order to be considered in the target. That's what this is for. And I can show you the way the hand and target block works is it only will tell you are in the target if the absolute center of the hand feedback is in the target, like this one. So this, even though these targets are touching, that's not considered in the target. Here, the absolute center of this hand feedback is within the target, so now you're considered in. So that logical radius can help you tweak, oh, I want it to be just inside as soon as this touches, or maybe you want it to be considered in the target when you're fully inside the target. Either way, kind of depends on what you're trying to do with your experiment, but that's what that logical radius is about, is helping you tweak that sort of relationship. Okay. So a lot of the show target block is about the show target block just shows static targets. Just you define a location, and that's where the target shows up. Something a little more interesting to do is creating moving targets. So if you want to create moving targets, we would recommend that you take a look at the task programming guide. And in the task programming guide, there is a table. There's a big section on how to manually manipulate targets. What do these V codes look like? What's in the array? How do we interpret what's in the array? The important part here, if you are attempting to create a moving target, is you will notice items 3 and 4 in that array are the X location and the Y location of the target. And so if you have your array, change elements 3 and 4, you'll be changing its position. Something important to know about that in particular is that everything that is drawn on the screen is within what we call the global frame of reference. So the global frame of reference on the subject display is the 0, point is basically the center of that monitor, the center of the subject display closest to the subject's forehead. So that's going to be 0, 0. Anything on the subject's right is positive X. Anything on the left is negative X. And then as you move away from the subject, that's positive Y. So as you're moving things around, just be aware of that. And these values are always going to be in meters as well. So SI units. We try very hard to do as much as possible in SI units. There is one small place that we deviate from that rule, and that's when dealing with the target table, because figuring out target positions in meters is much more complex than thinking of them in centimeters. So if you want to do a moving target, most of the time the easiest way to do that is going to be break out and do some embedded MATLAB code. So in this case, what we're doing is we start out with a show target block that's going to create our basic target, in this case a circle, and then we pass it into a embedded MATLAB block. So we take in our V code and we output a V code. And what this is doing is just over time we are taking this V code, whatever position it was at, we're moving out a certain distance, and then we're rotating the target around that location. A useful thing to remember in here is this persistent variable. Persistent variables in the context of programming your Kinarm can be enormously valuable. These are variables that do not change between calls for your their value is remembered in between calls of this function. So each time I call this function, whatever the last value of counter was, it's still going to be there. So that's why I can just say counter equals counter plus beacon time step. So basically each time this function runs, it's just going to get, this counter variable is just going to be incremented over and over again. So really, really handy for doing this sort of work. Okay. So in terms of the dynamic control you have, because you have full control over what goes into that V code, and we give you all of the definition of what's in that V code, you can pretty well control anything you want. So based on the previous example we showed, you can change your subject's or a target's position and make it move around the screen however you would like. But beyond that, you can control a target size, color, shape fully dynamically if you so desire. So if you want your target to pulse in and out to get someone's attention, changing size like that, totally doable. It's just changing the and if it's a circle, just change the radius over time, and we'll be changing the size of the target for you. Change colors, all of it very, very doable. We have a few extra types of targets. So there's the basic shapes, your circle, rectangle, triangle, ellipse, and line. But then we have a few other special cases. So the of paths, polygons, and repeat targets. So paths and polygons, a path is basically a joined segment of lines, and you can have up to 25 segments in a line. That we will draw. There's a good example on how to do that and a good demo on our website. And the polygons, similar idea, except it's enclosed, and you can have up to 25 vertices. And again, there's a good example on how to make polygons on the website already. We don't provide blocks for doing any of these because they're much more complex and much more conducive to handling them dynamically. So a block is not necessarily useful for making any of these targets. So for these ones, you're probably going to need to look at the examples and look at the task programming guide. The repeat targets, these are effectively any standard target can be converted to a repeat target. And the idea here is that if you have a 1 centimeter red circle defined, a repeat target would allow you within one vcode to show that 1 centimeter radius red circle up to 25 times. So this can be, if you need to throw a lot of targets on the screen, this can be an efficient way of passing us that information without having to send us 25 separate vcodes. You can do it all in a single vcode. And as I mentioned, there's no great way for using any of these from the target table or any blocks. To do these things will be straight embedded MATLAB. Okay. So again, these are the blocks that we provide. So we've talked a bit, obviously, about process video commands and what it does, and show target. So the other ones here that are that you might find useful: show target with label. So that one allows you to put text on the screen. So you just need to give us a little bit of extra data. So you need to, in your target table, create columns that tell us how high the text should be, and then columns that actually have the text in them. So this is going to be for if you want to do static text, like maybe you need a go signal or something like that. You can use this block. There's also ways to do dynamic text, but this is going to be a good place to start to show you how text is done. The set target in background. This one is a bit legacy at this point, honestly, just because previously we didn't have the capability to show all that many targets at one time, around 30. So if you wanted to show 200 targets at a time, you needed to send us all of the targets in the background, and then we would store them and display them every time without you needing to resend them. But not really necessary anymore. Right now, you can send up to 200 vcodes at a time to the process video commands block, and so we can display up to 200 vcodes at a time. So wouldn't really worry about the set target in background. It's kind of legacy for now. But as I've been mentioning along, to double click on any of these blocks to get the help out of them, and if you have any trouble with the help, if it doesn't make sense, let us know. We're always trying to fine tune that and make it as understandable and useful as possible to everyone. So we're always happy to know, or we love being told when there's something wrong so we can fix it. The other thing that's useful with these blocks is it's always good to, if you're wondering how do we do something, right click on the block, look under mask, and take a look at our code. See how we that can be very useful to you, especially so say for instance with the show target with label, that can be, if you want to do your own dynamic text, you can look at, okay, how do we actually make text happen in a regular V code. All right. So to summarize, uh, got lots of things you can do with the visual stimuli. So you can have your static versus dynamic targets. You can have things changing state all the time. Um, so, you have your targets change color when someone reaches them. You can do, lots of interesting dynamic things. Show, you can, as you saw yesterday, you can show images. You have lots of control that way. And then when you're actually dealing with a hand in target block, you have control over things like when is your hand considered in the target or not, and all of that's going to really depend on your the science you're trying to do and the exact nature of your experiment. But hopefully everything is there to give you the flexibility you need to accomplish everything you need. And if it's not, then again, that's something we love to hear about. If there's something you're trying to do and running up against a wall and you can't do it, maybe there's some secrets to doing it that we'd like to help with. And uh, but if not, then that's something we also want to know about, because if your science is interesting and you can't do something, then we want to help you do that science, and maybe other people are going to be interested in that paradigm. So, if you can suggest a feature to us that you would like to see, then we'd love to hear that as well.